Our choice for a top-level load balancing is called Traefik. Unlike Nginx servers that are perfect solution for static content, that ingress was designed specifically for microservices environment. Its automatical discovery on any change in your Docker containers allows it to scale effortlessly if you have like frequent updates and a lot of microservices under heavy development. And more important, it's HTTPS certificates management that doesn't require regular maintenance, so it becomes a run and forget solution. Configuring Traefik is conducted by putting Docker labels on the Docker containers. And roughly speaking, to add microservice to a load balancer, you will need to provide labels with configuration for 4 types of resources. From left to right, first, Entrypoints are actually unique ports that should be open on a host machine. In production configuration, it is always be just HTTP and HTTPS ports. But for local host, where we don't have virtual host, it can be any set of ports. Each port can emulate separate virtual host or machine or subdomains. Middlewares are intermediates that should extend, transform, or deny the requests, or modify the responses outside of the actual microservices. Routes configuration is actually the descriptions of what virtual hosts and what paths should match for Docker container to receive traffic. And services are the references of what Docker containers will receive traffic and what service ports should be mapped. Now we are making Terraform module called Traefik, and this will be our load balancer instance. Just like in the previous steps, we start with introducing input variables. We will use our internal network module, and hosted zone is the short form of introducing domains or open ports. Here, we accumulated commonly used expression in local variables. And we are planning to have one more Docker network called public. It will be our external network to contain only publicly available microservices. Big disclaimer here, you should not probably use latest Traefik image. The configuration that you will see later for HTTPS was actually tested with version 2.11 and not with the 3rd version. For certificate storage, we are introducing special Docker volume. We are leaving ports configuration to be defined dynamically because it will not be that trivial, but on the first stage we just want to separate that definition from the actual Docker container resource. Same with labels. The definition for all the labels is complicated. Honestly, it will be like 2 pages of concatenation and ternary operators. Luckily, that has to be done just once and then reused. In this demo, I made an exception to demonstrate all the logic behind the process done from the very scratch. Same with command line arguments. It will take us a few minutes to have definition for them, so we are holding it to be defined above. Okay, so we can forget about Docker resources now and focus on definition of ports, labels and commands of our load balancer container. As I was mentioning, there will be 2 different strategies for using ports. In production or staging environments, domains always have HTTPS certificates, so the only ports that remain open there will be HTTP and HTTPS. But on localhost, we don't have virtual hosts, So we will need to allocate dedicated ports for each future domain or subdomain during development. This is what is described in hosted zones variable and HTTPS variable. Routes rules will be defined mainly based on host name. Entrypoints configuration basically mirrors our ports with the command line arguments for Traefik application, for production, and for localhost. In the command line arguments except entry points, we are configuring our Docker provider and we will enable Traefik API, dashboard UI and login. And it looks like we are done with command line arguments. Now it is time to work on our labels. There are labels that should be added to containers of all public microservices. And now, what came in the short form of hosted zone became more extended version called public zone. As a variable, it will be reused for all microservices that we are going to make public. And we include as much variables as possible, so it could be easy to build proper labels for the future microservice. We are finally ready to concatenate all labels of our load balancer into one list. For a local environment or for educational purposes if you wish, we could configure Traefik dashboard to be available on a dedicated port or on subdomain. Dashboard presence can help in error resolution if you are new to configuring Traefik. Finally, we make zones map to be output variable. This is how our file system looks now. We are done with reusable module for Traefik load balancer, and now we need to extend our application layer with new variables and add our new module. Admin email is the person who will receive alerts from Let's Encrypt. The tricky part here is to accumulate routes rule for multiple virtual hosts that would be reused easily later. Okay, I miserably failed. There is an error in this line, but you will discover that only in a few minutes. We are getting to the finish. The remaining modules are in the workspace layer, where we should define our virtual hosts. This is where local and production configuration will be different. For the local environment, I'm configuring a zone for application on port 7777 and one for Traefik dashboard on 7780. And on the remote host, I will not have Traefik zone. The microservice will be running the demo domain, and free HTTPS certificate should be provided by Let's Encrypt. The configuration looks good so far. We've done a nice job of introducing the load balancer, and this is probably would be done once and never repeated. But what is repeated is actually making microservices public when load balancer is already configured and running. This is what we will do now with our microservice that was already deployed in the previous two videos. Now we share our microservice with the world. We should add public zone variable to encapsulate all the public properties. We should add the container to the public Docker network. For some reason, I'm delaying with the correct network ID here. And the biggest part, we should collect all the labels. Please don't be scared about their complexity. Once these labels are set for one microservice like this, they can be just copy-pasted to all other public microservices. The differences will be only in paths, service names, and service ports. Okay, it's finally time to test local installation. And of course, there are errors that I face and have to correct. The assumption that port I need is free was false, so I will just choose another one to avoid conflict. 7799 looks fine. We see that our microservices are running. When I try ports 7780, it responds with Traefik dashboard redirection. And after I'm trying the correct default zone port, we have what we expected. Now it's finally time to see how configuration works in production. Just like we did earlier, we copy all Terraform files to a remote host. Go to Workspace folder and try to apply Terraform plan. And here on a confirmation step, I saw an error. Backticks are missing in the host rule. So let's locate that error and fix it. After reapplying Terraform plan, it looks like everything has started. But we have self-certificate problem. The normal way to check what is the source of such issue is to check logs of Traefik. But that logs showed nothing, and in fact there was no actual issue. It just took 40 seconds for Let's Encrypt to receive certificate. And I was panicking for no reason. The microservice started to work as it should. I hope you enjoyed that video as much as I did. So in the next video, we will start writing microservice that will provide a custom API. So stay updated to witness the whole process.